Electronic technology is a shining star in today's world of science and technology. It has given wings to the entire field of science and technology, powerfully accelerating global progress. Especially in the past 50 years, the rapid development of microelectronics has brought about remarkable transformations in industries such as manufacturing, agriculture, science, and national defense. A wide range of electronic products, including mobile phones, televisions, and personal computers, have become indispensable parts of daily life and are influencing, even reshaping, our everyday experiences. Development of electronic technology. The development of electronic technology is largely reflected in the advancement of electronic components. In 1904, the world's first vacuum tube was invented by British physicist Fleming. The birth of the first vacuum tube marked the beginning of the electronic era. Most vacuum tube radios used two sets of DC power supplies, one for the filaments and one for the anodes. Advantages: improved reception performance. Disadvantages: bulky size, high power consumption, high cost, fragile structure, and requirement for high-voltage power supply. In 1910, Dunwoody and Picard developed the crystal radio. This was the simplest radio receiving device, with only one semiconductor component in the circuit, sufficient for one person to listen. In 1925, John Logie Baird developed the television. In 1946, Americans Mauchly and Eckert developed the first general-purpose electronic computer, ENIAC. It was composed of over 18,000 vacuum tubes, weighed more than 30 tons, and occupied the space of several classrooms. It was a massive and bulky machine. Its invention was epoch-making and had a profound impact on human history. In 1947, William Shockley and his two assistants, Bratton and Bardeen, developed the first transistor at Bell Labs, marking the start of the transistor semiconductor era in electronic technology. On October 18, 1954, the world's first transistor radio hit the market, containing only 4 germanium transistors. In 1958, China successfully developed its first domestically produced semiconductor radio. At that time, owning a radio was a status symbol for ordinary people. In 1958, Kilby developed the world's first integrated circuit. Since then, integrated circuits gradually replaced transistors, making the emergence of microprocessors possible and ushering in a new era in the history of electronic technology. From large-scale integration in 1969 to very large-scale integration in 1975, and later to ultra-large-scale and super-large-scale integrated circuits, the evolution continued. In 2017, Huawei launched the Kirin 970, the world's first mobile AI computing chip, manufactured using 10 nanometers technology and containing 5.5 billion transistors on a chip the size of a fingernail. This course covers semiconductor devices such as semiconductor diodes, bipolar junction transistor, and field effect transistors. Analog electronic circuits that process analog signals and their fundamental functions. Various amplifier circuits, operational amplifier circuits, filter circuits, signal generation circuits, power supply circuits, etc. Analysis methods for analog circuits, graphical analysis, small signal model method, ideal model method, etc. The roles of different electronic circuits in electronic systems. Features of the Analog Electronic Technology course. 1. Engineering-oriented. Practical engineering requires feasibility validation. Emphasis is placed on qualitative analysis. In actual engineering, as long as basic performance requirements are met, a certain margin of error is generally acceptable. Quantitative analysis of electronic circuits is referred to as estimation. Approximate analysis must be reasonable. Focus on the primary contradiction and the key aspects of the contradiction. Electronic circuits are, fundamentally, electric circuits. Different models are used to estimate different parameters, and electronic circuits can be analyzed using basic circuit theory. 2. Practicality. Practical analog circuits almost always require debugging to achieve the desired outcomes. Therefore, the following methods must be mastered. Proper use of common electronic instruments such as multimeters, millivoltmeters, signal generators, and oscilloscopes. Techniques for testing electronic circuits. Methods for fault diagnosis and troubleshooting. Application of EDA software, Multisim, PSpice. How to learn this course. 1. Master the basic concepts, basic circuits, and basic analysis methods. Basic concepts. Concepts are constant. Applications are flexible, ever-changing but always rooted in the same foundation. Basic circuits. Construction principles remain unchanged. Specific circuits vary widely. Basic analysis methods. Different types of circuits have different performance indicators and descriptive methods, thus requiring different analytical approaches. 2. Pay attention to the application of circuit theory in electronic circuits to better understand specific circuits. 3. Learn to analyze issues in electronic circuits dialectically and comprehensively. The most suitable circuit for a given requirement is the best circuit. Evaluate pros and cons. There is usually no gain without a trade-off. Therefore, this course includes theoretical teaching, laboratory experiments, and course projects to solidify theoretical foundations and develop practical skills. Assessment methods. 1. Circuit recognition. Qualitative analysis to determine and understand circuit functions. 2. Calculation skills. Quantitative computations. Not only should you calculate circuit parameters, but also component parameters. 3. Selection skills. Choosing circuit types, components, and parameters. Assessing problem solving and design abilities. 4. Debugging skills. Use of instruments, testing methods, fault diagnosis, and EDA tools. Assessing problem solving and hands-on capabilities. This course includes theoretical instruction, experimental training, and project design. You may refer to the following textbooks. 1. Foundations of Electronic Technology, Analog Section, 7th edition, edited by Konghua Guang and Zhang Lin, Higher Education Press. 2. Fundamentals of Analog Electronic Technology, 5th edition, edited by Hua Chenying, Higher Education Press. 3. Foundations of Electronic Technology, Analog Section, 7th edition, edited by Zhang Lin and Chen Daqin, Higher Education Press. 4. Key and difficult points in analog electronic technology, problem-solving guidance, graduate exam guidance. 5. Example problems and solutions in analog electronic technology, compiled by Chen Daqin. That concludes today's lesson. Goodbye, everyone.